Hello again, everyone. We are back with part 2.6 on powering the Siemens S7-1200, especially CPU 1212C, which is powered by an AC current. What's important to know before we move on to any other parts of PLC modulation, especially conveyor for conveyor belt system, it is that you power up the PLC correctly so that it doesn't damages the hardware in the long run, and it would be safe without having any fire or any burns in the system. That's why we are putting together this part 2.6 to make sure the current and voltage that goes into the PLC module is in accordance with what is specified by Siemens. The table of content for this little short video is similar to this. We are basically going to go through the data sheet published by Siemens for CPU 1212C, ACDC again, and we also need to know that what is the wire ratings in terms of AWG, and so in simple terms, what sort of thicknesses should you use for your wire to make sure that the current passing through the wire wouldn't damage the wire itself, because as soon as the wire catches fire, then the whole system will be um, gone. That's not what we want. So we need to make sure that there's enough thickness provided for the current to go through, and also not so thick that will be over designed and over engineered because it's just adding cost to the whole system. The difference between current divider and a wire connector will be explained, and what effects can it have on the whole system if they are exchangeably and mistakenly used. And there's a bit of a conclusion at the end as well. Moving on to the data sheet published by Siemens, what we can extract from this data, you can find this data sheet online, just Googling your Siemens part, and you can extract this from internet pretty easy. It says input current, you can find it on the first page, and it refers to the inrush current, which also can be referred as the maximum amount of current that can go through the PLC module, is rated as 20 amps at 260 volts AC again. So if and there is also another piece provided on the top row that says current consumption is at 80 milliamps at 120 volts AC, or 40 milliamps at 240 volts AC. So that's the minimum and maximum basically. To run this PLC module, you would need at least 80 milliamps or 40 milliamps, and the maximum amount I can go through is 20 amps. So just have that in mind for safety and for not going over engineered with the design and with some additional costs. Then we have AWG ratings and the currents. What type of wire, you can ask yourself that, what type of wire can I use to power my PLC? Here we have AWG. So we've extracted from the Siemens data sheet that 20 amp is the maximum, and anything below that basically all the way down to 40 milliamps is okay. So if we look at this table, on the first column on the left, you can find the AWG rating, and on one, two, three, four, five, six, on the sixth column, you can see the amperage for a copper wire, and it's a single core. The number of cores means how many cores you can see inside the cross section of the wire. So with the 20 amps, which was taken as the maximum, an AWG 14 is enough. But for safety reason, I've chosen AWG 12 because there's always fluctuation in the system, in the power that's coming from the grid. It always goes ups and down by a huge amount. So for to be safe, I just chose AWG12, which can carry out 34 amps. But just to be marginally okay, you will be pretty good to go with AWG16 and AWG14 as well. Here on the second and the third column, you can also see the diameter of the wires. And what happens normally when you go to shop and find something on the shelves, AWG is not given unless you're in America. From what I've understood in Australia, the ratings are mostly in millimeters. So the diameters are given in millimeters. And I found out that AWG12, which is a 22.1 mil wire, is just more than enough for PLC Siemens S7-1200. And it is also important to know the current divider, the differences between a current divider and wire connectors. Wire connectors are passing through the exact same amount of current that comes in to the next, this is a second wire, it's a connector. So if you're getting power from the grid from the outlet in your house and try to connect it to the PLC, with a wire connector, you would exactly get the same current um, once these two wires are connected. So if 20 amp comes in from the outlet on in the house, you get 20 amp on the other end as well. But with a current divider, for this example, we have four outputs and one input. So if 20 amp goes in with this current divider, you can get something reduced because that 20 amps is now divided into four different currents. And if we're assuming that all the resistances um, after the divider are equal, then it is logical to think a 5 amp to be distributed in a system. But if there's only one wire going out of the output from this current divider, then 20 amp will be um, not transformed into any other values of current. So 20 amp with a one output will be 20 amps. But if you have four wires connected to this current divider, it would be good if we can calculate 20 divided by 4, which is 5 amps going up. So with a current divider, you can expect to get reduced amount of current going in the system if you have all the current of all the outputs connected to something. So that was it. Thank you so much. Um, be safe with your PLC modulation. Don't burn your system because you're probably spending too much money and time to um, modulate these automated systems. And also, we are here to do the research for you, especially if you're a construction business owner. We understand that how busy you can be with your daily task, and if you're pursuing somehow to reduce your amount of workload by bringing an automated system in your daily operations, which is pretty much a trend these days. Everyone wants to pass their tasks to AI and all the automated systems. And here we are. We are giving all of these research for free, available to you. There are online courses also available for you to enroll in, and again for free. Um, yeah, so many resources available. Enjoy and see you for the next part.